Hi everyone. Today we'll be discussing the LeetCode problem of the day. Find the minimum amount of time to brew potions. So in this problem, you are given two integer arrays, skill and mana of length n and m respectively. So in a lab, you have n wizards and they have to brew m potions in order. And each potion has a capacity, and that potion must pass through all the wizards sequentially from the first wizard to the last wizard. And the time taken by the ith wizard to brew the jth potion will be skill of I into mana of j. And it's also given that in the brewing process, it is delicate, so a potion must be passed to the next wizard immediately after the previous wizard completes. Suppose, let's see the example. We have three wizards here, and their skill levels is as follows: 1, 5, 2, and 4. So if you want to brew this potion, which has the mana 5, so it will go through all the wizards in order. So first it will go to the first wizard, and he will take 5 into 1, 5 seconds of time to brew this. So after 5 seconds is done, immediately the next wizard should start the brewing process, and this wizard will take 5 into 5, 25 seconds to brew this. So this wizard will take 25, so the total time elapsed so far is 30. So after 30 seconds, it will go to the next wizard, and this wizard will start the process. So he will take 2 into 5, so he'll take 10 seconds to brew this. So he got it at 30 seconds, he'll take 10 seconds, so at 40 he'll be done, and immediately the next wizard should start. So it is not like this wizard can start at t equal to 42. If it is done at 40 by the previous wizard, he should immediately start at 40 seconds only. So this wizard will take 4 into 5, 20. So 20 plus 40, 60. So that means this first portion will go through all the wizards, and by the time of 60 seconds, this first portion is brewed. So at the end, you just have to return the minimum amount of time required for all the portions to brew properly. So we saw that for the first portion, it took 60 seconds. And after that, you will pass this portion, this, and this. And for all the portions, the maximum time it will take is 110 seconds. So we'll see how it is later. Also note that suppose for this portion, let's say wizard 3 will be done by wizard 3 will be done by 60 seconds. So that means if you want to brew the second portion, you can't start this brewing process before the 60-second mark, because a wizard can't parallelly work on two portions. So only after 60 seconds, this wizard number 3 can start working on the other portions. Okay, so now let's just see the example. So the example, first the portion 5 arrives. So like we discussed, let me just write it again. Values 1, 5, 2, 4. Yeah. So the first portion, 5 into 1, 5. It will be done by 5 seconds. The second wizard will take 5 into 5, 25. So 25 plus 5, it is 30. And the second wizard, 5 into 2, 10. So 30 plus 10, 40. And the third wizard will take 5 into 4, 20. So 40 plus 60. Total, at time equal to 60, all the portions are done. So now we want to go to the next portion. So he wants to start brewing this portion at time equal to 52 seconds. So when we do that, at 52 you start, and this wizard 0 will take 1 into 1, which is 1 second. So wizard 0 will be done by 53 seconds. And then next wizard 1 into 5. he'll take 5 seconds, so 53 plus 5, 58. And similarly wizard 2 will take 2 seconds, so 60, and wizard 3 will take 4 seconds, so 64. And then you will start brewing the potion number 2 at 54 seconds, and wizard 0 will take 1 into 1. Okay, you're at this potion. So wizard 0 will take 4 into 1, 4 seconds, so he'll be done by 58. And then wizard 1 will take 4 into 5, 20, so he'll be done by 78. Wizard 2, 4 into 2, 8, so 86. Finally, wizard 3 will take 4 into 4, 16, so he'll be done by 102. And finally, for the potion number 3, you will start brewing it at 86 timestamp. And so we are at here, 2 into 1, 2, so 2 seconds. Now 88 plus 10, 98, that is 2 into 5. So the second wizard will take 2 into 2, 4, so 98 plus 2, 102. And the last wizard, 2 into 4, he'll take 8 seconds, so 102 plus 8, 110. So by 110, all the potions are brewed, so the answer is 110. Also, he states that if you want, for the first potion, you can't start brewing the potion before 52 seconds. So this is the minimum time you have to wait. So what he means by that is, suppose you start brewing this potion at 50 seconds. So at 50, let's see what happens when you start brewing at 50 seconds. So for this potion, you brew at you start at 50. So the first wizard will take 1 into 1 second. So first wizard will be done by 51 seconds. I mean the 0th wizard. So now the first wizard will take 1 into 5 seconds. So 51 plus 5, 56. Second wizard will take 1 into 2 seconds. So he'll be done by 58 seconds. So second wizard is done by 58 seconds. So at 58 seconds, the third wizard should start working on this. But as we can see for potion number 0, the third wizard is still working. He's not done yet. So till 60, he'll be working on the potion 0, and only after 60, he'll be free. So here we can see there's a 2-second gap. And since we can't have any gaps in between the potions, so we can't start at 50. So here we can see the gap is exactly 2. So that's why we have to start the brewing process at 52 seconds. So while discussing the approach, we'll see exactly how much time we have to delay so that we will complete all the potions optimally. So let's also quickly check the input 2. So again, we have 3 wizards. All the values are 1. So the first potion, it will take 1 second for the first wizard, and for the second wizard also it will take 1 second, so total 2 seconds. For the last wizard, he will receive at t equal to 2, he'll also take 1 second, so at t equal to 3 he'll be done. So this is for the 0th potion. Now for the first potion, we will start the process at 1 second. I'll also take a start. So here we'll start at 0. So first potion will be done by 1 second, and so on. So for the first potion, we will start at 1, so that the 0th wizard will be done by 2 seconds. The first wizard plus 1, 3, and the last wizard plus 1, 4. And finally, for the last potion, let's start the process at t equal to 2, so that at t equal to 2, he will take 1 second and he'll be done by 3. So at 3, he'll take 1 second, so he'll be done by 4, and again 4 plus 1, 5. So at the end of 5 seconds, all the potions are brewed, so the answer is 5. Now let's go over the approach. So to solve this, we can just do a simulation for all the potions and see what is the time taken for the last potion to be done. So I'll be taking the first example. So we have four wizards, and I'll just also write the skill values of them, 2 and 4. So let's just calculate the time for the first portion, for the 0th portion. So this is pretty straightforward. First it will be 5 into 1, which is 5. Then next 5 into 5, 5 into 5, 25. 25 plus the previous value, which is 30. And 5 into 2, 10. So 10 plus the previous value, 40. And finally 5 into 4, 20. 20 plus previous value, 60. So this is the end times for all the wizards to brew the 0th potion. So that means wizard 0 will be done by 5 seconds, wizard 1 by 30, wizard 2 will be free by 40 seconds, and wizard 3 will be free by 60 seconds. Now we want to compute for the remaining portions. So the 0th portion is done. So let's move on to the next portion. Now to brew this portion, I'll just keep track of the time. So initially at t equal to 0, I want to give it to the first wizard. Let me just bring it down. Yeah. At t equal to 0, I want to give it to the 0th wizard. But I can see that this wizard is not free until 5 seconds. So I have to wait 5 seconds and then start the process. So I'll also keep a variable delay. Initially it is 0. So since I have to wait 5 seconds, I'll add 5 seconds in the delay. And after waiting 5 seconds, I will give this portion to the first wizard, and he will take 1 into 1 second. So this wizard 0 will be done by t equal to 6, because he takes 1 second to brew. So that means at t equal to 6, I am giving this portion to the next wizard. So wizard 1 will get the portion at t equal to 6. But again, we can see that he is not free until 30 seconds. So that means we have to wait 30 minus 6, 24. So we have to wait 24 more seconds. So let's add it in the delay. Plus 24. So the delay means that how much time we wait before starting the process. So this is basically the start time. So we wait 24 seconds. So that means at t equal to 30, this first wizard will get the portion, and he will take 1 into 5 seconds. So by 35, this wizard 1 will be done. And then he will give it to the next wizard, wizard 2. Again, we can see wizard 2 is not free until 40. So the delay is 5. We need to add 5 more seconds to the delay, so that after 40 seconds pass, wizard 2 will be free, and he will take 1 into 2 seconds. So at 42, he'll be done. Now finally, we can see again wizard 3 will get the portion at 42, but he's not free until 60. So we again have to wait another 18 seconds to start the process. So after 18 seconds, 60 will be done. 60 seconds will elapse, and he will take 1 into 4 seconds. So at 64, this wizard, this portion 1 will be completed. So we can see portion 1 will be completed by 64. And delay, if we add all of this, 20, 38, 42, 52. So that means to brew the portion 1, we have to wait 52 seconds and then start it, so that all the wizards will be done with their previous portions. So we can see in this table, we have to wait 52 seconds to start the process. So once we get the 52, what we do is we calculate the end times for the portion 1. So we started 52, it will take 1 second, so 53. and next 53 plus 5 58, 58 plus 2 60, 60 plus 4 64. So since once we get the start time, we can easily calculate this by doing the prefix sum, like similarly how we calculated for the portion 0. So in this way we got the answer for the first portion. So similarly we will do it for the second portion as well. So I'll quickly do that as well. So again I'll take delay equal to 0 and initially time equal to 0 and t equal to 0. Okay, now we are on to this portion. So t equal to 0, I want to start brewing this portion, but we can see that the 0th wizard is not free until 53, so the delay is 53. And time will be 53 plus, he will take 4 seconds, so 57. So the 0th wizard will be done by 57 seconds and he will give it to the next wizard. So he is not done by 58, so we also need to add 1 second delay. So now at 58 he will start brewing. So 4 into 5 20. So at 78 this wizard 1 will be done. Now we can see that for the wizard 2, wizard 2 was done at 60 and he got the new portion at 78. So he's free, so he'll simply work on it. We don't need to add any delay. So he will take 2 into 4 8 seconds. That means 78 plus 8 86. And again for wizard 3 as well, he's done by 64 and we got the portion at 86, so there's no delay. So he will take 3 into 4 12. 4 into 4 16. So by 102 he'll be done. So after this we can see that the 102 is matching and the delay is 53 plus 1, it is 54. So once we get the delay, we'll just compute the end times for all these wizards. So delay is 54, so first wizard will be done by 58 and then the next wizard 78, 86, 102. So this is the end times for the portion 2. Now finally let's take a look at the last portion and then we'll be done. So for the last portion, no delay initially and you want to start at t equal to 2. But again till 58 seconds the wizard 0 is not free, so you will wait for 58 seconds and then you will brew this portion and this will take 2 into 1 2 seconds. So total wizard 0 will take 60 seconds to be done. So at 60 you will give it to the first wizard, but he is not done by 78, so you have to wait 78 minus 60 18 seconds plus 18. So he'll get it at 78. 2 into 5 he'll take 10 seconds, so by 88 he'll be done. Okay, 1 second. At 78 he'll start and his value is 5, so 5 into 2 is 10. Yeah, so he'll be done by 88. Now we move to the next wizard. Now we can see it is 86, so there's no delay and he will take 2 into what is this, 2 into 2 4 seconds, so 92. And at the end we can see again here we need to add a delay because till 102 the wizard 3 is not free, so we'll add plus 10 delay and 102 he'll be free and he will take 2 into 4 8. So total 110. And the delay is 58 plus 18, 68, 76 plus 10, 86. Delay is 86, which is matching, and the answer 110, that is also matching. So at the end, we'll again compute the answer for the last last portion. So 88, 98, 102, 110. And all the portions are done, so we break out of the loop and we just return the value of the last wizard when he's done. So this is just this is the approach. At each step we will check if our time is less than the previous wizard's completion time, we will add a delay. If it's not, then we'll simply add the working value, and at the end we'll just return the last value. Now let's quickly code the approach. So first let me take the length and m equal to mana.length, and here I'm using a long variable to store all the time because the return type is long as well. Long previous end. So here we'll just pre-compute the previous end values of the 0th portion, and then using that we'll start iterating on the rest of them. So we have previous end of 0, it will end on skill of 0 into mana of 0, and for the remaining values we have previous end of I equal to I minus 1 plus the same thing, skill of I into mana of 0. So for 0 I've written it separately because since we are checking with I minus 1, so if I put I equal to 0 here, this will go out of bound. So for I equal to 0, we won't have any of this term, so we will just have skill of 0 into mana of 0. So I've written it separately. So we have computed the end times for all the wizards to brew the 0th portion, and now let's start for the remaining portions. J equal to 1, j less than m. Now let's take two variables, delay equal to 0 and also time equal to 0, and let's start iterating on all the wizards. 0, then I plus plus. So for the first wizard, we'll first check if our time is greater than equal to the previous end time of that particular wizard. So if this is true, then we don't need any delay, and we'll just add in the time, we'll just add the time he requires to finish it, skills of I into mana of j. Else case means time is less than previous of end. In that case we need a delay, so delay plus equal to the previous end minus time. So how much ever is the difference, that we add it in our delay, and then time will be previous end plus this value, the time he takes to complete it. Yeah, so once this is done, we know the exact delay we have to wait. So using this delay, we'll calculate the end times for the jth portion. So we can copy the same thing here. But here previous end of 0 equal to, we'll add delay plus skill of 0 into mana of j, and previous end of I equal to previous end of I minus 1 plus skill of I into mana of j. So using this delay, we are computing for the jth portion, so that in the next iteration we will use it to calculate it. So once this is done, all the processing is done, at the end we'll just return previous end of n minus 1. So the last the time the last wizard will take to complete is what we have written. And if I'll submit, yeah, it works. Finally, let's go over the time and space complexity analysis. So for the time complexity, we have a loop running n times, and this loop will run m time, and inside this loop we are running n and n. So total time complexity will be order of n into m. And for space complexity, we are creating a long previous array and some few variables. So space complexity will be order of n, because this size is n. And I also have the code in Python. If anyone wants to view it, I'll add it in the description as well. And let's catch up in the next video.